For our biomechanics group project, we chose to analyze the deadlift. In the field of biomechanics, we are to look at movement in order to enhance performance and minimize injury. In these two pictures, you can see a proper deadlift being performed. The first picture shows the start position, and the second picture shows the end position.
Comparing these two photos, you can see how the hip, knee, and ankle joint move through the sagittal plane. We analyzed these joints later in the presentation. Form is very important in the deadlift.
Common mistakes done during the exercise will result in improper form. Such mistakes include improper use of back muscles and improper muscle activation. Also, using the upper body rather than lower body will result in improper form.
Improper form can lead to an increased risk of injury due to unnecessary torque and force distribution on the joints. The most common injury is disc hernias, specifically between the L4 and L5 vertebrae.
Next, we will talk about motion concepts. This includes the relevant joints, the prime muscles, the position, velocity, and acceleration concepts, and Newton's laws relative to the deadlift.
During a deadlift, we look at the hip, knee, ankle, shoulder, and lumbar spine. The hip will start in flexion with a range of motion of 100 to 125 degrees and will end in extension with a change range of motion of 100 degrees. The knee will start in flexion with a range of motion of 100 to 125 degrees and will end in extension with a change range of motion of 100 degrees. The ankle will start in dorsiflexion and will use plantar flexion to get to neutral. The shoulder will start in flexion with a range of motion of 35 degrees and will use extension to get to neutral. The lumbar spine will remain in the neutral position.
The prime muscles that are being activated throughout the deadlift include erector spinae, gluteus maximus, quadriceps, hamstrings, and adductors. Stabilizing muscles include trapezius, rhomboids, serratus anterior, rectus abdominis, gluteus medius, gluteus minimus, soleus, and gastrocnemius.
As the load increases, the velocity will decrease. The joint accelerates to a stop at the top of the motion. This is then reversed until the bar is back on the ground.
Newton's first law is that every object will remain at rest until an outside force acts upon it. In a deadlift, the external force acts on the bar, which is at rest. Newton's second law is that the acceleration of an object is produced when a force acts on a mass. In a deadlift, acceleration of the bar is caused by a net force in one direction. Newton's third law is that for every action, there is an equal and opposite reaction. In a deadlift, the bar exerts the same amount of force on the hands as the hands do on the bar.
Finally, the weight being lifted and the center of mass of the upper body and arms are relatively long way from the vertebrae, and this creates a huge torque about the lumbar vertebrae.
This included video of the deadlift being performed will show you the correct form and the incorrect form. The first 2 reps are correct form and the last 2 reps are the incorrect form.